Hello, everyone. Greetings and welcome to another episode on Oral Pathology 360. When we think about any cancer, there are two things that come to mind. If we could stop its indefinite growth, and if we could stop its being able to establish itself in different far away metastatic sites, then we would have literally overcome cancer. Of course, we are still not there, but through the years, it has been found more and more that the microenvironment, the tumor microenvironment, which is modified by the cancer itself, is in control and can be modified. And there's a lot about it. And today we will be hearing about all of those things from Dr. Swapna. Now, sorry, a little lost here. Right. So another thing, in case you have been, interested and going with the tumor microenvironment, we also had a uh, puzzle that we updated and put up on the website, which was a word search, and all you had to do was literally find those words related to tumor microenvironment, and you could answer that. You can still do that. The link is in the description of the video. It will be great if you go and actually do that. Now, yes, and as always, I forgot. So, in case this is your first time, I'm Dr. Mandana Donahue, founder of Oral Pathology 360, and it is indeed a pleasure to have everybody here. This is a channel dedicated to oral and maxillofacial diagnostics. So, everything that's pathology, medicine, and radiology, and of course, the specialized branches of dentistry that deal with the diagnostics. So, everybody is welcome, and also general medicine and pathology. Coming to today's lecture, it is by Dr. Swapna Amod Patankar, Tumor Microenvironment of Head and Neck Squamous Cell Carcinoma. Now, she's Assistant Professor, Department of Oral and Maxillofacial Pathology, I'm sorry, and Oral Microbiology, Bharati Vidyapet, deemed to be University, Dental College and Hospital, Pune, India. From the rest of the things that she does, you will notice that she's very active in a number of things. She's a researcher. She is, of course, an academician with over 21 years of experience, and she is a invited guest speaker, author, and also doing her PhD right now. She's all in all very active, and anyone who is on social media would have normally seen her sharing some of her achievements online. So we'll not take more of that. Welcome, Dr. Swapna. It's lovely to have you here with us. Thank you for joining. With that, we'll just go ahead and we will watch the lecture, which is a recording, so we do not have problems with the speed of internet. And then we'll get back together and have the question answers. Please remember, any questions you have, you can type in the chat. For that, you need to be logged into YouTube using your Google account, I assume. And that's it. We'll catch up on the other side of the lecture.
A very good evening to you all. I'm Dr. Swapna Amod Patankar, Assistant Professor in the Department of Oral and Maxillofacial Pathology and Oral Microbiology at Bharati Vidyapet, deemed to be University, Dental College and Hospital, Pune, Maharashtra, India. I would like to thank Dr. Mandana Madam for giving me this opportunity to present at this international platform, Oral Pathology 360, where we meet and connect with like-minded professionals. Knowledge is a deep ocean, has no limit. The more you learn, the lesser it is. This is so aptly true for my today's topic of discussion, tumor microenvironment and head and neck squamous cell carcinomas. I will be covering my presentation under the following headings. So let's begin with the introduction to tumor microenvironment. What is a tumor? It's an abnormal mass of tissue that forms when the cells grow and divide more than they should or do not die when they should. Tumors may be benign or malignant. What is cancer? Cancer is not one disease, but a collection of related diseases that can occur almost anywhere in the body. Genes control the way our cells work. Changes in the genes can cause the cells to malfunction, causing them to grow and divide when they should not, or preventing them from dying when they should. These abnormal cells can become cancer. What is tumor microenvironment? According to the National Cancer Institute, the tumor microenvironment is defined as the normal cells, molecules, and blood vessels that surround and feed a tumor cell. A tumor can change its microenvironment. The changes in the microenvironment can affect how the cancer cell grows and spreads. Studying the microenvironment may help researchers to understand how the cancer cells form and find new ways to treat cancer. Tumor microenvironment is the environment around a tumor, including the surrounding blood vessels, immune cells, fibroblasts, signaling molecules, and the extracellular matrix. The tumor and the surrounding microenvironment are closely related and interact constantly. Tumors can influence the microenvironment by releasing extracellular signals, promoting tumor angiogenesis, and inducing peripheral immune tolerance, while the immune cells in the microenvironment can affect the growth and evolution of cancerous cells. Now let's see the history of the term tumor microenvironment. Way back in 1889, Stephen Paget's gave a theory of seed and soil. He explained the interplay between the tumor and its microenvironment. He postulated that metastasis of a particular type of a cancer, which he termed as the seed, often metastasizes to the certain sites, which he termed as the soil, based on the similarity of the original and the secondary tumor sites. In 1960, Glenn and his colleagues found an anti-tumor immune response mediated by lymph node cells to cancer cells derived from the primary tumor. The primary tumor established a microenvironment that was functionally analogous to that of the normal tissues. In 1991, Boone studies of antigens that elicit specific CD8 plus T cell responses in cancer provides a proof of possibility of tumor microenvironment immune suppression. Thus, everything is theoretically impossible until it is done, and hence a lot of research is being done to find out more information about the tumor microenvironment and its influence on progression of cancer. So let's see the components of the tumor microenvironment. With recent advancements in detection and treatment, the outlook on cancer has changed dramatically. The tumor is no longer viewed as a bulk of malignant cancer cells, but rather as a complex tumor microenvironment, in which other subpopulations of cells, which are corrupted by the cancer cells, are recruited into, and they form a self-sufficient biological structure. Very truly said, every drop in the ocean counts. So does every cell of the tumor microenvironment counts when it comes to spreading of the cancer. These are the different cell types which are found in the tumor microenvironment. These subpopulation of the cells interact with each other as well as the cancer cells via complex communication networks through various cytokines, chemokines, growth factors, and proteins of the extracellular matrix. So let's see each one of them in briefly. Cancer-associated fibroblast. They are the predominant cell types within the tumor stroma. They are elongated spindle-like shape and share similarities with mesenchymal and smooth muscle cells. They are derived from various progenitor cells as shown in the diagram. Their main function is to maintain a favorable microenvironment for tumor cell growth and proliferation. Cancer-associated fibroblasts promote cancer invasion by matrix remodeling. They interfere with the T cell function by immune crosstalk. They promote tumor growth through variations in metabolic effects, and they also promote macrophage and endothelial crosstalk by secretion of various factors. Let's see the next component, that is macrophages. Macrophages are mononuclear phagocytes, basically the immune cells, which play a role in both innate and acquired immune response against pathogens. They are either M1 or M2. M1 are the pro-inflammatory macrophages which produce in tumor necrosis factor alpha, interleukins, as we can see, n number of interleukins and chemokines. Their main function is pro-inflammatory, microbial and tumoral activity and tissue damage. The anti-inflammatory M2 macrophages to produce interferons. They also produce chemokines and tumor growth factor beta. Their main function is anti-inflammatory, tissue regeneration, repair, phagocytosis, angiogenesis, immunomodulation, tumor formation, and progression. But now these macrophages are modified to tumor-associated macrophages in a tumor microenvironment. And now they will contribute to proliferation, invasion, metastasis of tumor cells, promotion of tumor progression, angiogenesis, and suppression of the T cell anti-tumor immune response. Thus, they cause a lot of havoc in the tumor microenvironment. A lot of studies have been done which have suggested a correlation between the levels of infiltration of the tumor-associated macrophages and the poor outcome in the head and neck squamous cell carcinomas. So these tumor-associated macrophages may be used as a potential prognostic marker. Coming to the next entity, the neutrophils. Neutrophils are the first line of defense and have adaptive immunity responses. Neutrophils are able to form neutrophil extracellular traps by releasing their cytotoxic, cytosolic, and granule proteins on a scaffold of decondensed chromatin in a cell death process called as netosis. Neutrophil extracellular traps activate platelets, promote thrombosis, and increase the risk of cancer-associated venous thromboembolism in the head and neck squamous cell carcinomas. The tumor microenvironment modifies them or modulates them to tumor-associated neutrophils. They are of two types, anti-tumor N1 phenotype and pro-tumor N2 phenotype. The exact role in cancer progression is yet under study, but it definitely helps in progression of the cancer. Coming to the next entity is the regulatory T cells. This is a unique subset of T cells which are responsible for maintaining self-tolerance, homeostasis, and regulation of other immune cells, that is the CD4 and the CD8 T cells, the B cells, the natural killer cells, macrophages, and the dendritic cells. Vignali et al. Arranged the mechanisms of these regulatory T cells into 4 modes of action. Suppression of inhibitory cytokines, suppression of cytolysis, of killing the target cells, suppression of the effector T cells, and suppression by modulation of the dendritic cells. Coming to the next entity, myeloid-derived suppressor cells. They comprise of a heterogeneous population of immature inhibitory immune cells in various stages of myelopoiesis. They play a very crucial role in the negative regulation of the immune response in many pathological conditions, cancer as well as inflammation, by inhibiting both the adaptive and the innate immunity. Thus, in this diagram, we can see that the myeloid-derived suppressor cells, they will inhibit the T cell function, the natural killer cell function, and the B cell function. And ultimately, they transform themselves to the tumor-associated macrophages, thus causing a havoc in the tumor microenvironment. The myeloid-derived suppressor cells have the ability to suppress the activity of T cells in head and neck squamous cell carcinomas. They have been linked to processes within the tumor microenvironment, such as promotion of tumor angiogenesis, degradation of the extracellular matrix through matrix metalloproteineases 9, and formation of the pre-metastatic niches. Coming to the next entity, platelets. Every coin has two sides, so does our platelets. Platelets have physiological functions as well as they play an important role in pathology. We can see how they affect the various structures, tissues, and cause a havoc in their pathological function. They mainly promote malignancies of solid tumors leading to metastasis. The platelets mediate the tumor microenvironment via three types of secretory granules: dense granules, lysosomes, and alpha granules. During platelet activation, the cargo from these granules is carried into the extracellular environment. There is a platelet aggregation, a vasoconstriction, and regulation of cell proliferation, and ultimately there is secretion of numerous growth factors. The dense granules contain mainly small molecules like ADP, ATP, calcium, serotonin, and others like lysosomal associated membrane proteins. The lysozymes, they contain an acidic pH as they contain acid hydrolysis, which degrade and remodel the extracellular matrix and vasculature. The alpha granules attracts the other cells to form tumor cell platelet embolies and thus stimulating tumor cell growth and angiogenesis. Coming to the next component, that is mast cells. Mast cells get modulated to tumor-associated mast cells in the tumor microenvironment. They have both anti-tumor actions as well as pro-tumor actions. But now, when they are converted to tumor-associated mast cells, their pro-tumor actions are aggravated. They are namely angiogenesis, extracellular matrix degradation, and direct and indirect immune suppression. Coming to the last entity, the natural killer cells. They play a crucial role in the innate immune system. They secrete interferon gamma and tumor necrosis factor alpha. The natural killer cell function is tightly regulated by two different types of receptors present on the cell surface. These are activating and inhibitory receptors. The MAGE histocompatibility complex class 1 molecules are expressed on healthy cells and act as inhibitory stimuli, preventing the natural killer cells activation. But in a malignant or a virus infected cell, there is a down regulation of this major histocompatibility complex class 1 expression. And this will allow the malignant or the virus infected cell to escape the cytotoxic T cells. The tumor microenvironment now modifies them into natural killer T cells. Now, these natural killer T cells show morphological and functional characteristics of T cells as well as the natural killer cells. They have one subset called as the invariant natural killer T cells, which is been seen to have low levels in the peripheral blood of the head and neck squamous cell carcinoma patient, which indicates a poor prognosis. Coming next to the extracellular matrix. This is a non-cellular network of macromolecules, including fibrous structural proteins, glycoproteins, growth factors, and proteoglycans that form a structure providing other surrounding cells with physical and biochemical support. In cancer, this extracellular matrix becomes deregulated and disorganized, which directly stimulates the malignant cell transformation. They produce high amounts of matrix metalloproteinases, which are produced by the stromal cells in the tumor microenvironment as the fibroblasts and inflammatory cells. Now let's see the role of these matrix metalloproteinases in extracellular matrix. They are attributed to their capability of degrading the extracellular matrix and helping the tumor cells migrate to local and distant sites. They activate growth factors or release them from the matrix, thus promoting initiation and proliferation of primary tumors. They are involved in tumor angiogenesis by activating the basic fibroblast growth factor, the endothelial growth factor, and the tumor growth factor beta. So these are the changes that take place in the extracellular matrix in a tumor microenvironment. Proteins in the extracellular matrix, namely the collagen, elastin, fibronectin, laminin, and tenascin, influence the cell adhesion and proliferation and provide a structural support along which the cells migrate out of and into the tumor microenvironment. Over a period of time, this elevates the stiffness of the tumor compared to the surrounding normal tissue. This impacts on cancer progression by activating oncogenic intracellular signaling and inhibiting the tumor suppressor genes and thus promoting tumor progression. So in this diagram, we can see a normal extracellular matrix, and here we can see invasion of the cancer cells, and we can see the stiffening of the uh, extracellular matrix that takes place. The fibronectin in the extracellular matrix provides a binding and interaction site for several other molecules present in the extracellular matrix, such as integrins, fibrin, heparin, tenascin, collagen, gelatin, and signican. These are associated with tumor progression, migration, invasion, and reduced responsiveness to treatment. All of this leads to a directional migration of cancer cells. We can see this directional migration of the cancer cells. Coming to the next entity, that is metabolic reprogramming of the tumor microenvironment. A common feature of rapid progression of solid tumors is intratumoral hypoxia. This is due to the insufficient oxygen supply to the tissue. In rapidly growing tumors, there is a fast exhaustion of available oxygen, which stimulates an upregulation of production of the pro-angiogenic factors to form new blood vessels. These newly formed blood vessels tend to have a tendency of high leakage and irregular structure, which impair their function. Hypoxic microenvironment has also been implicated as a crucial contributor to radio and multi-drug resistance. So as we can see in this diagram, as the tumor microenvironment starts building up, we can see the stiffness that is taking place. At the same time, the oxygen levels tend to reduce in this tumor microenvironment, making it hypoxic. Hypoxia leads to upregulation of hypoxia-inducible factor 1. Now, this plays a role as a key player in mediating the adaptive cellular response to low oxygen levels in the microenvironment. It regulates expression of genes associated with tumor cell growth, survival, proliferation, and genes involved in cellular energy metabolism. It also leads to a Warburg effect, in which the glucose undergoes glycolysis to form lactate, and thus increasing the tumor metastatic potential and resistance to the treatment. All of this promote to the creation of a more advantageous tumor microenvironment for the cancer cell to proliferate, survive, and invade. Now let's see the role of the tumor microenvironment in pathogenesis of the head and neck squamous cell carcinomas. Now, a growth of a potentially malignant lesion to oral squamous cell carcinoma is associated with elevated expression of the extracellular matrix components, namely the tenascin, matrix metalloproteinases 2, and fibroblast growth factor 2. Significant infiltration of the pro-inflammatory immune cells, such as the tumor-associated macrophages, the CD8 plus T cells, and the natural killer cells. There is a shift in the inflammatory cytokine profile with increased levels of interleukin 17 and 23. There is a secretion of many pro-inflammatory mediators, namely the chemokines, and all of this suggests that the microenvironment of potentially malignant lesions to be more immune stimulatory. As we can see in this diagram, from the low dysplasia, as it progresses to an invasive cancer, we can see that there is a multiplication of these cells. At the same time, in the microenvironment, we can see cytotoxic T cells, M1 and M2, tumor-associated macrophages, myeloid-derived suppressor cells, and the T regulatory cells. So all of them are going to modulate the tumor microenvironment, which promotes the growth, progression, and invasion of these cancer cells. Elevated mast cell density significantly is correlated with microvessel density. Increased presence of the cancer-associated fibroblasts leads to progression from a pre-malignant lesion to an oral squamous cell carcinoma. As we can see here, this is a oral potentially malignant lesion, and how it progresses to an oral squamous cell carcinoma as there is a degradation that takes place of the basement membrane, and we can see the tumor cells invading the extracellular matrix or we can call it as tumor extracellular matrix now, which is modulated by different components. As we can see, there is hypoxia, there is hypervascularization, there is increased solid stiffness that takes place. A lot of factors are released which are going to promote the growth of the tumor cells, evading them from the immune cells or the immune system, and thus leading to further development of the primary tumor invading the underlying connective tissue. Now let's see the growth of a primary tumor. The presence of immune cells cause inflammation as tumor-infiltrating lymphocytes, the CD8 plus cytotoxic T cells, the CD4 plus helper T cells, the natural killer cells, and the regulatory T cells. There is also infiltration of the tumor-associated macrophages, which contribute to the inflammation in head and neck squamous cell carcinomas. There is neovascularization, poor prognosis, lymph node metastasis, and low survival rates in these patients. There is a high neutrophil infiltration, which indicates a higher tumor stage, recurrence, and lymph node metastasis. Thus, the oral squamous cell carcinoma is associated with the poor clinical outcomes and poor survival if there are high neutrophil infiltration rates seen. Mast cells produce pro-angiogenic factors which lead to extracellular matrix degradation, angiogenesis, progression, and growth of a squamous cell carcinoma. Higher presence of the natural killer cells indicates an improved survival in head and neck squamous cell carcinoma patients. Increased levels of T regulatory cells in head and neck squamous cell carcinoma patient has been correlated with cancer recurrence. High abundance of circulatory myeloid-derived suppressor cells correlates to advanced stages of head and neck squamous cell carcinoma as it promotes cancer cell proliferation. Increased number of cancer-associated fibroblasts is correlated with the worst prognosis of head and neck squamous cell carcinomas as they enhance the production of various tumor-promoting cytokines, chemokines, components of the extracellular matrix, growth factors, and matrix metalloproteinases. Major extracellular matrix proteins, that is collagen, laminin, and fibronectin, are involved with head and neck squamous cell carcinoma development and progression. So all of these factors are working together to create a tumor microenvironment which will promote the growth of the primary tumor. Epithelial mesenchymal transition. This is a dynamic process in cancer development during which a polarized epithelial tumor cell acquires a mesenchymal phenotype. This shift is characterized by loss of cell adhesion and upregulation of various components of the extracellular matrix, increased migratory potential, and enhanced invasiveness. The epithelial mesenchymal transition is associated with loss of proteins involved in cell junctions such as E-cadherin and beta-catenin, with an upregulated expression of mesenchymal markers such as alpha smooth muscle actin, vimentin, ferroptosis suppressor protein 1, and N-cadherin. This is associated with tumor progression and an increase of metastasis in head and neck squamous cell carcinomas. Stromal cells are proteolytically formed to degrade the basement membrane and underlying collagen matrix. They develop invopodia. These are nothing but extensions which are filament-like given out from the tumor cells which are responsible for degradation of and invasion through the extracellular matrix. The invopodia facilitate the extracellular matrix degradation in head and neck squamous cell carcinomas through regulation of various matrix metalloproteinases. MMP2 and MMP9 cause local invasion, cervical nodal metastasis, tumor progression, and the prognosis is affected in the head and neck squamous cell carcinoma patients. Their activity is regulated by the tissue inhibitors of metalloproteinases. These are type 1 and type 2. The type 1 expression has been associated with poor survival in head and neck squamous cell carcinomas. Hypoxia is a crucial hallmark of cancer, and for formation of the invopodia, induction of the epithelial mesenchymal transition, and migration and invasion of the cancer cells. Now let's see how do these tumor cells survive in the circulation. Tumor-associated endothelial cells, tumor cells, and collagen type 1 cells protect these tumor cells from achinosis. After entering the circulation, a platelet cloak is formed, as we can see in this diagram. The platelets surround the tumor cells, forming a shield which enables the tumor cells to evade the immune systems. Now let's see how do they extravasate into the tumor environment or at a second site. There is an arrest of the tumor cells on the endothelium, which is followed by transendothelial migration and invasion into the surrounding tissue. Platelets promote extravasation and transendothelial migration. Induction of the epithelial mesenchymal transition, invasiveness in the tumor cells at the secondary metastatic site. So as we can see here, how the extravasation has taken place and how it is going to form a secondary tumor. Cancer cells revert back to the epithelial mesenchymal transition induced mesenchymal phenotype in order to adapt to the microenvironment of the secondary metastatic site to allow the colonization and metastasis. And now the expression of E-cadherin will be seen in this metastatic tissue. Thus, in a nutshell, the tumor microenvironment will definitely influence the pathogenesis of head and neck squamous cell carcinomas through various aspects as discussed. We have epithelial mesenchymal transition, invasion, metastasis, anoiquis resistance, and angiogenesis, immune invasion, metastatic niche formation, therapeutic resistance created, and sustained proliferation. All of this will lead to a poor prognosis of an head and neck squamous cell carcinoma. Now let's see something different. How does the tumor microenvironment can be used for a targeted therapy in head and neck squamous cell carcinomas? A lot of studies have been going on, a lot of experiments are being done in vitro and in vivo to develop a target therapy which will act on the tumor microenvironment and can be given to patients who are resistant to the cancer therapy. They are currently researching on cancer vaccines, which release and presentation of antigens is involved, priming and recruitment of immune cells. So they are causing a resensitization of the T cell effectors, infiltration of immune cells into the tumor and the tumor microenvironment. So here an immune modulation of immune suppressed tumor microenvironment can be targeted. Recognition of the cancer cell. So here we can think about adoptive cell therapy and death of the cancer cell. So there should be an increase in the antigen presenting cells numbers in the tumor microenvironment. Some recent updates. Ocean of knowledge together with experience gives wisdom. Thus, a remodeling the tumor microenvironment with emerging nanotherapeutics. So again, a lot of research is being done by using nanotherapeutics, which target specific components of the tumor microenvironment. So as we can see, the extracellular matrix gets targeted by the nanotherapeutics, which disrupts the tumor extracellular matrix. They target the tumor hypoxia by delivering oxygen. They target the tumor-associated fibroblasts by disrupting their formation, and they will target the tumor vessel formation in the tumor microenvironment. Gaining knowledge is the first step to wisdom, and sharing it is the first step to humanity. Scientists from Mumbai, Tata Institute of Fundamental Research, Agharkar Research Institute Pune, and IIT Hyderabad have discovered a new therapeutic agent, ruthenium ferrocene bimetallic, which has a potential to curb the primary tumor growth through anti-proliferation, anti-angiogenesis, and preventing metastasis. So they're trying to kill two birds in one stone. Did you know that head and neck cancer awareness is with a burgundy ivory color ribbon on a helping hand support? This is a symbolic bow color for the oral, throat, laryngeal, and pharyngeal squamous cell carcinomas. April is the Head and Neck Cancer Awareness Month, and International Oral Head and Neck Cancer Awareness Week will be celebrated from 11th to the 17th of April 2023. So, we pathologists can bring about the awareness about head and neck cancers in the general population from 11th to 17th of April 2023. Thus, to conclude, the emerging evidence of crucial contribution of different stromal components to the regulation of the head and neck squamous cell carcinoma development indicates a fundamental role of tumor microenvironment in providing a supportive niche and thus promoting head and neck squamous cell carcinoma development and metastasis. In-depth understanding of the stromal composition of the head and neck squamous cell carcinoma microenvironment, their impact on cancer development and progression will definitely aid in better understanding of the mechanisms behind the different responses to the therapies and a possible targets for clinical intervention. If we develop in-depth knowledge, it will enable us to give our best to the others and help to make a better world. Thank you.
So we are all ready for the questions. Thank you, Dr. Swapna. That was a very nice presentation. Very, very well done. Thank you. So, yes, now
Thank you, ma'am.
while welcome. I mean, you didn't get a chance to say hello, so you can take that chance now.
Yes. First of all, I would like to thank Dr. Mandana Madam for giving me this platform where I can connect with like-minded people from oral pathology, as ma'am has said, diagnosis. And I have been seeing all the videos and all the interactions that have been taking place on this oral pathology 360 platform, and they have been a very inspiring and all of them are so thought provoking that yes, you feel that the ocean is quite deep and you have to go deeper to understand oral pathology. I am really thankful to all the audience who are here, and I have tried to give a brief review of the components of tumor microenvironment and how they can affect the progression, the invasion, and the prognosis in head and neck squamous cell carcinomas. This is a very brief kind of a presentation that I have taken today because of time constraints, and each factor of these components of tumor microenvironment can definitely be a special lecture on each one of them, because there is so much research going on tumor microenvironment that we have to study them in depth to understand them and how they help in progression of cancer, and most importantly how we can come up with strategies to tackle patients, head and neck squamous cell carcinoma patients who are nowadays showing a resistance to the treatment. So this tumor microenvironment can provide a target mutation therapy for treating cancers. So again, as a lot of research is going on, so definitely there will be in future some nanotherapeutics available to tackle cancer therapy, like for the head and neck squamous cell carcinoma patients.
Very true. So there are already some comments that are saying thank you for a very good presentation. Hi, Sandhya. Well, I cannot take credit for that topic choice. It was her own choice. Dr. Swapna chose it. I generally tell everyone speak about something you love to talk about, and I get the best topics like that. So this was something she chose to speak about. So really, not my contribution there. And Dr. Revati is actually waving. That's what it is.
Hello,
Yeah.
ma'am.
And Dr. Nasser also saying beautiful review and comprehensive. Thank you. Dr. Manusmurti also saying thank you for the wonderful lectures. And Dr. Suganya also saying well explained. We do seem to have a question here. Very there, Dr. Sandhya. Controlling acidic interstitial pH and making it alkaline has also been a recent cancer research area. Very interesting. I'm always interested in the pH. Okay. Yes. Would you like to say anything about that?
Yes, the acidic interstitial pH is going to definitely promote further damage to the extracellular matrix that is there. And as we have seen, so many factors they are interrelated to each other, and how this tumor microenvironment is modulating these normal cells of the extracellular matrix, and these cells ultimately cause acidic pH. They will also stimulate certain metabolic effects like the Warburg's effect, where we saw that the glucose gets shows glycolysis to lactate, and this effect will further promote progression of cancer cells. So these acidic pH controlling definitely can be a target therapy, so that less damage can be caused to the extracellular matrix that is forming around.
Quite. Then we have one more question. Dr. Suganyas, any relevance on diabetic individuals?
Well, actually, I have not as specifically seen any articles right now. I may have not referred them. There may will be articles or studies which are conducted on diabetic individuals who are showing head and neck cancers. But for my this review, I have not researched on this aspect. But definitely, I will read up on it. Thank you so much, ma'am.
I think there is this whole thing about the metabolic syndrome associated with, so one would assume that diabetes will have something to play there,
Yes.
considering the role of its role in metabolism. Okay, so we have Dr. Lingappa also, who says very well explained. Thank you for being with us. And Dr. Revati has put in a number of comments. She's first said very well done. Then she has said she works with me. So I assume you work with
Ma'am
Dr.
is my head
Revati.
of department. Ma'am is my head of department.
Okay. Yes. And mischievous ma'am has not been coming to the channel. I have called her so many times and she keeps making excuses. Dr. Revati, you heard, I hope. So now
It's
she's going
ma'am's
to say, well,
blessings
someone from my
and
department is come.
her blessings and her motivation has always helped me to, do better and better in my field. Thank you
Yes,
so
you're
much,
good,
ma'am.
good friend too. So yes, she is proud of your work. I can see why. Then we had some colleagues who joined us a little late and we couldn't say hi to them. So let's say hi to everybody. Dr. Afreen joined us and Dr. Salami. Hi, I think this is the first time Dr. Salami has joined. And Dr. Mayondi. Yes, so lots of friends from around the world. It's lovely to have everybody here.
Yes.
And any other questions? Any thoughts? Any questions left? I find it always very interesting when it comes to the microenvironment, the tumor microenvironment, especially. Of course, I have a vested interest in fibrosis and fibroblasts. I'm more interested in those than in anything else. But it's very interesting that if you see normal fibroblasts, the inherent tissue fibroblasts actually do not allow. They are like what I would say. They are static. They stop the growth or the multiplication of the cells. They reduce the multiplication of the cells. It's only when the fibroblasts get converted into cancer associated fibroblasts, which
Yes.
means they have been modified, then they actually help the progression. And I think it's the same with all the cells. And it's very
Yes.
interesting actually. Sorry, have I lost you? Oops, I think Dr. Swapna is momentarily lost. Let's see.
Ma'am, I'm here only.
Oh, okay. I thought we lost you. Yes. Okay. We also have Dr. Vivek. Hi, Vivek. Nice to have you here. Okay. Yes. So, what have you found specifically about fibroblasts? Anything besides what you already mentioned in the lecture? I'm cheating, of course, because I'm sitting here and I'm organizing things, so I'm taking a little extra advantage.
Ma'am, as you have mentioned about the fibroblast physiological role, so today I have shed light on the pathological aspects or the roles which cancer associated fibroblasts can cause and havoc, like the cancer associated macrophages. So, all these cells in our normal extracellular matrix are actually maintaining the balance, but once it becomes a tumor microenvironment, each one of them has an evil role. This is what I would say,
Yeah,
and this helps the cancer cells to evade the cytotoxic T cells and progress through the processes of EMT, MET, transition, intravasation, extravasation, and all this will promote the metastasis of the cancer. So somewhere these fibroblasts, if when during the exit of the tumor cells from the blood vessel to the distinct site to form the secondary tumor, also these fibroblasts are helping, cancer associated fibroblasts are helping these tumor cells to exit the blood vessels and enter into the distinct metastatic site where they want to form the secondary tumor. And along with them, definitely the platelets are there, the cancer associated macrophages are there, and other natural killer T cells are there. So I think all of them are working hand in hand in this evil aspect, I feel, of promoting the cancer cells.
that's true. It's once they're modified, they just stop
Yes,
doing what would be their normal
yes.
activity, and they're
They
sort of
literally cause a complete
hijacked.
havoc. Yes.
Yes,
And they cause the stiffening also of the extracellular matrix. So that also is going to give a channelizing to
yes.
the cells to progress for metastasis.
That's true. But it's interesting that not just any stiffening, because which we have found in oral submucous fibrosis, although
Yes.
there is stiffness, but oral submucous fibrosis, the original fibrosis is not cancer associated. It's just normal
Yes.
scarring like tissue. And it does not allow really, it does halt or it does hamper the multiplication or the progress of a cancer, but it's
Yes.
only after they are changed that they
Yes.
actually begin to cause
Yes.
it. It's a very interesting line, actually. Right? I think we have reached the end and there are no more questions. So, what remains is for me to say thank you so very much. And I will send you, of course, the certificate. And once you get your PDF, so there in this part which has the picture of the YouTube, there's an actual link embedded. So from your digital certificate, you can anytime go to your lecture.
Thank you so much, ma'am, and thank you everyone for joining.
You're most welcome. I think everybody enjoyed. So that was very nice. Thank you so much for being with us, Dr. Swapna. Yes, and it was a very, very interesting and very informative lecture. So
Thank you,
now,
ma'am.
with that, let's go on to, yes, next week. So I have to tell you all what is upcoming. Next week, we have a recorded lecture from Dr. Tilak Ratne. This was a lecture that was given during last year's conference. It's very interesting. It was everything, a very comprehensive and yet, I would say, precise presentation of everything that was in the WHO 2022 as far as the tumors of the oral cavity and the mobile tongue went. So that will be shared next week, and I hope you will join us. And right, sorry, I seem to have lost something here. Okay, since I seem to have lost that picture, but okay. So, what I would like to also say that the dates are out for the international conference. The 2023 conference is going to be on the 13th and the 14th of May. Please mark your calendars, and the link is there in the description. Right now, it is just the date, but you can go to the website where it is shared, and you can choose to get information, so that when as we find the details and we finalize the details, you will know, you will be amongst the first to know. Please remember, you can start looking for your cases. There will be case presentations, of course. And last year many said that they didn't have enough time to choose their best cases, so we are giving you like ample time this time. So go ahead, look for your cases and be ready. Also, additionally, this year, of course, last year we already had the proceedings as a PDF, but this year we are going to have, besides the proceedings, the abstract book, which will be a PDF, but we will select cases and print the complete cases that are reviewed by a group of editors and who decide that those cases are fine. So they will be actually published as an edited book, so that you will actually be able to cite your work and share your work as a printed work or as a published work. So that is the other thing that's happening. So definitely go and look for your cases. It's time. It's that time of the year, right? And with that, let me say thank you for being with us. Hope you will join us next week too at the same time. And in the meanwhile, if the content gives you, well, any worthwhile information, if you enjoy being here, please definitely like this video, so Dr. Swapna also knows that this is that this you appreciated it. And well, subscribe if you haven't done before, and definitely share the video and comment on it. If you interact with the videos, then it gets a better ranking and it will get shown to others who search for any oral pathology topic. Yes, and Dr. Sandhya is saying this is a good time. Yes, it is, I guess. It is a good time. It's a different time, anyways. And you could make it. I'm glad you could make it. So, thank you, everybody. Have a wonderful, wonderful week, and we shall meet you again next week.